Bismillahirrahmanirrahim. Assalamu alaikum. I am Dr. Ahmad Nauman, and this is our second lecture related with the hydrochloric acid industry. So this is the outline of our today's lectures, that what we are going to discuss. So in previous lecture we had some brief overview of hydrochloric acid and its properties, its history. We also discussed natural sources of hydrochloric acid, and also we discussed about some general characteristics and toxicity of hydrochloric acid. In this lecture we will discuss about the global HCl production, that what is the trend of HCl production and what are the main major industries where HCl is used, and what are the major countries utilizing the HCl worldwide. And then we will also discuss some important chemical properties and reactions of HCl, for example with carbonates and bicarbonates, with sulfites, with metals, and also with metal oxides and metal hydroxide. And then we have to discuss in detail some methods which are used at industrial scale for the production of HCl, and then in the last we will discuss the major uses and application of hydrochloric acid. So some of those materials we will discuss in today's lecture, and the remaining will be discussed in the coming lectures. We discussed in our previous lecture that HCl is highly toxic to human beings and environment, as well as many animals and or other aquatic organisms. So अगर कुछ चीज़ बहुत ज़्यादा टॉक्सिक है तो मे बी we think maybe it's with the time, because these days there is a lot of focus on green technologies and those kind of things. So maybe it's जो uses हैं जो HCl है या जिसको production है, maybe वो कम होनी चाहिए because it's very toxic. However, when we actually look at the facts, so it shows कि जो HCl की production है that is increasing by every year. Its requirements are increasing by every year. For example, in this diagram you see that as compared to 2013, the production of HCl in 2018 and 2019 is almost double. So this graph is actually showing the production as uses of HCl in different continents, like some in Asia, in Europe, in America, and it's expected that by 2024 its production and requirement will increase by maybe 2 or 3 folds. So the question arises that even though that HCl is so much toxic, then why there is increase in demand of HCl, and why there is enhanced use of HCl globally? The answer to that question, that why we have increased requirement for HCl worldwide, is due to the widespread application and uses of HCl in different industries. So when we have an overview of hydrochloric acid market when considering end user industry globally, so this is the report that is published in 2018. So we see that the majority of HCl is used in steel industry and in oil and gas industry. Almost 45% of HCl used worldwide is consumed in these two industries. And then there is a big share of HCl which is used in chemical industry and in textile industry, and also there is significant portion of HCl that has been used in the food and beverages. And And also there are some other applications for example rubber industry, and there are some other industries where HCl used. So it is because of these widespread applications of HCl in various industries that its demand is growing by every year worldwide. That was about the global consumption of HCl in different industries, but it do vary from specific continent to one continent to another continent, and in the continent it also vary from individual countries. So in different areas and in different countries there will be different uses of HCl. For example, when we talk about the annual usage of HCl in United States of America, so there we find that major portion of HCl of around 28% is used in the manufacturing process of organic chemicals, and around 3% of HCl is used in ore processing, 3% is used in the regeneration process of resins, and around 4% is used in pharmaceuticals, and also 4% is used in the acidification of oil wells. And 8% of HCl is used in steel pickling, and around 10% is used in the brine treatment process. Around 12% of annual use of HCl is for the food processing, and 13% is used in inorganic chemicals, and the remaining 15% have different miscellaneous applications. However, this ratio of the usage of HCl in different industry will vary from country to country, and also with continent to continent. So that was the global use of HCl, or global production and its uses in different industries worldwide. How about if we have to predict that which country utilizes most of the HCl globally? So अगर हम ये कहें कि गेस करना हो कि कौन सी कंट्री है दुनिया में जो सबसे ज़्यादा जो है वो HCl यूज़ कर रही है, so what will be your guess? So you might guess US, or you might guess China, right? So by 2014, United States was the largest consumer of hydrochloric acid worldwide. However, from a report published in 2018, actually it's now China which is the larger consumer of HCl in the world, and that is understandable because of the huge industrial growth in China. So that's why it's because China has a lot of steel production, and that there are some other industrial application where HCl is used. So currently China is the leading consumer of HCl, and followed by United States and the Western Europe. And then the major countries and areas which are utilizing HCl worldwide include Japan, South Korea, Taiwan, Middle East, India, Eastern Europe, and Central Europe, and some South America and other countries. So this is how the HCl is used worldwide. Have learned that HCl has a vast range of application in different industries, and is used in worldwide in different continents. And now we will discuss some of the very important chemical properties, or the reactions of HCl with different chemical compounds. So first we will discuss about the reaction of HCl with carbonates and bicarbonates, that how HCl reacts with the metal carbonates and metal bicarbonates. And second important reaction of HCl is its reaction with the sulfites. So we will also discuss in detail about how HCl reacts with the sulfites. And after that, we have the reaction of hydrochloric acid with different metals, that how it reacts with different metals. And fourth one is we will discuss about reaction of hydrochloric acid with metal oxides and metal hydroxides. There are many other important reactions, for example its reaction with ammonia, and there are so many different important reactions of hydrochloric acid, but it is not possible to overview all of those. So in this lecture we will overview these four categories of reactions of hydrochloric acids. So let's proceed with the first one. So let's first discuss the reaction of hydrochloric acid with different carbonates and bicarbonates. So normally it's a common phenomena that when acids are different, they react with carbonates and bicarbonates. So what happens, they produce the corresponding salts, and in addition they release carbon dioxide gas and also produce water. In the case of HCl, whenever HCl reacts with carbonates and bicarbonates, it also produces the corresponding metal salt plus water, and always there is a release of CO2 gas. So let's see some reactions. So पहला जो हमारे पास रिएक्शन है वो है HCl का सोडियम कार्बोनेट के साथ. सो व्हेन हम ट्रीट करते हैं हाइड्रोक्लोरिक एसिड को सोडियम कार्बोनेट के साथ, तो क्या होता है कि फर्स्ट एज वी डिस्कस इट शुड प्रोड्यूस द corresponding metal salt. So the salt of sodium will be sodium chloride that will be produced in this case. So and in addition there will be release of CO2 gas and there will be production of water molecules. Let's see another example. So when we treat calcium carbonate and hydrochloric acid, they produce salt of calcium chloride and they produce water, and in addition there is release of CO2 gas. And let's check an example of bicarbonates. So similar to carbonates, when we treat bicarbonates with hydrochloric acid, so we have the production of the corresponding metal salts as NaCl in this case, and plus we have same the release of CO2 gas, and there is also production of water in this case.
Take two test tubes A and B and add some amount of sodium carbonate in test tube A and sodium hydrogen carbonate in test tube B, and also add some amount of dilute hydrochloric acid to both the test tubes and observe what will happen. After adding dilute hydrochloric acid, we can see the evolution of gas with bubbling on both the test tubes pass the two gases separately through the delivery tube into calcium hydroxide, lime water in two test tubes. We observe a white dense precipitate which is due to formation of calcium carbonate and water. Thus we can conclude that the gas evolved in these two test tubes is carbon dioxide only. Chemical reactions. Test tube A. Sodium carbonate reacts with hydrochloric acid to give sodium chloride. water, and carbon dioxide. 2HCl plus Na2CO3 gives 2NaCl plus CO2 plus H2O. Test tube B, sodium bicarbonate reacts with hydrochloric acid to give sodium chloride, water and carbon dioxide. On passing excess carbon dioxide into lime water, forms calcium bicarbonate, which is soluble in water.
Is the reaction of hydrochloric acid with different sulfites. So HCl, when treated with metal sulfides, it breaks down sulfides into corresponding chloride salts, and in addition it produces water molecules, and during that reaction there is release of sulfur dioxide in the form of gas. So let's take an example. So when we treat sodium sulfide with 2 moles of hydrochloric acid, so that sodium sulfide is transformed into production of corresponding salt of sodium chloride, and there is release of sulfur dioxide gas, and also there is production of a water molecule. Let's take an example of potassium salts, and similar to the sodium sulfide salt, when we treat potassium sulfide with hydrochloric acid, so we have potassium chloride salt, and in addition to the formation of water molecule and the release of SO2. So now let's see a practical example of how hydrochloric acid react with metal sulfides and how this reaction actually proceeds. So let's watch an animation.
In the double displacement reaction of a metal sulfite with an acid, we'll start out with white sodium sulfite and add an aqueous solution of hydrochloric acid. The sulfite and the hydrochloric acid react to form sulfurous acid and sodium chloride. The sulfurous acid is not stable and decomposes to form water and sulfur dioxide. The sulfur dioxide escapes from the solution. We can test for the formation of sulfur dioxide by bringing in a moist piece of blue litmus paper. The sulfur dioxide dissolves in the water to form sulfurous acid, which turns the blue litmus paper red.
Another important chemical reaction is reaction of hydrochloric acid with metals. So when a metal reacts with hydrochloric acid, it again forms its corresponding salt, and here there is a release of hydrogen gas. So let's see an example. So when calcium metal is treated with hydrochloric acid, so it results in the formation of a corresponding calcium chloride salt and a release of hydrogen gas. So let's see another example. Similar to calcium, when hydrochloric acid reacts with sodium, so it forms sodium chloride and release of hydrogen gas. And similarly, the formation of magnesium chloride is observed when HCl is treated with magnesium metal, and it also produces the hydrogen gas. Reaction of zinc with hydrogen chloride results in the zinc chloride plus hydrogen gas. And another example is the reaction of iron metal with hydrochloric acid, and that actually produce the iron chloride FeCl2 beside the release of hydrogen gas. So whenever HCl reacts with different metals, so it always produces a corresponding salt of that metal, and there is a release of hydrogen gas. So let's see and watch an animation of reaction of hydrochloric acid with sodium metal. So let's watch the experiment that when we treat hydrochloric acid with sodium, so how the reaction proceeds. So let's start.
I'm going to add the sodium metal to the hydrochloric acid.
So in the last we have a reaction of hydrochloric acid with different metal oxides and metal hydroxides. So when HCl reacts with metals or metal oxides and metal hydroxides, so it produces salt and water. So let's see an example. When we treat copper hydroxide with hydrochloric acid, so it will result in the formation of corresponding copper salt, which is copper chloride, and there will be formation of water molecules. And when we treat hydrochloric acid with oxide of copper, which is copper oxide, then the reaction proceed in a similar way, and we again get the copper chloride and water molecule. So for both metal oxides and hydroxides, when treated with hydrochloric acid, so they result in the formation of corresponding metal salts and the formation of water molecules. And let's see two more examples of different metal oxides. So in case of sodium oxide, when it reacts with hydrochloric acid, so as expected, so it will form the corresponding sodium chloride salt, and it will also form water molecule. And when we treat magnesium oxide with hydrochloric acid, so it will form magnesium chloride salt and water molecule. So overall, जब भी हम मेटल ऑक्साइड या मेटल हाइड्रोक्साइड को रिएक्ट कराएंगे हाइड्रोक्लोरिक एसिड के साथ, तो हमारे पास उनके क्लोराइड साल्ट्स बनेंगे और साथ में जो है वो वाटर बनेगा.
Take a small amount of copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. The color of the solution becomes bluish green due to the formation of copper chloride and copper oxides dissolves. Metal oxide plus acid give salt plus water. CuO plus 2HCl give CuCl2 plus H2O. So metallic oxides react with acids to give salt and water.
So we have discussed some important reactions of hydrochloric acid. So next we have to study some industrial scale production of HCl. We know that historically HCl is produced from reaction of rock salt or green vitriol or we can say it's conventionally produced from the reaction of sodium chloride with sulfuric acid. But nowadays there are many other processes which are used at the industrial scale production of HCl, including the burner process, byproduct of chloralkali process, and similarly from chlorination process, and as a byproduct of organic synthesis. And hydrochloric acid is also produced from the organic waste incineration. So we will have to discuss all of these methods in details, and we will look into these in our coming lecture. So thank you so much for your attention. So that's all for today's lecture, and inshallah in next lecture we will discuss in detail about the production or industrial scale manufacturing of hydrochloric acid. And in case you have any problem with this lecture, or you don't understand anything, so please let me know. Thank you.